Everyone. So we have another set of questions for MathCON prep. So this was number 5 on the practice test. So we have a combinatorics problem, right? So Anna takes a math test with 2 sections, each has 4 questions. And to pass the test, she has to have at least these 2 requirements. So 2 questions correctly in each section, and also 5 questions correctly in total. And she selects 5 out of 8 problems randomly and answer them all correctly. What is the probability that she's going to pass the test? Okay, like we do need to know, like she's choosing 5, right, out of 8 problem, and then she has to choose 2 from each section. So she could choose like 2 out of 4 problems, because there are 4 different questions. She can choose any of those 2, which is basically 4 choose 2 ways that she can choose 2 of these questions on the first section. And if she chooses 2 questions on the first, then she needs to choose 3 questions from the second section. Second section also has 4 questions, and then that is 4 choose 3. And this is one thing she can do, or she can do other way around. She can choose 3 from the first and 2 from the second. And the value of these will be just swap. And that's why I'm going to just multiply this by 2 instead of writing twice. And this is the desired outcome. But the total outcome is going to be 8 problem, and then she needs 5. So that's just 8 choose 5. And that is what we are going to need. Okay. So if I simplify this, that will be 2 times 4 choose 2 is like, some people remember this immediately. 4 times 3 over 2, which is 6. Okay, some people are trying to use a formula, which I don't use it. And then 4 choose 3 is the same as 4 choose 1, which is just 4. And this is divided by 8 choose 5 is okay to find it, but I think it's better to use 8 choose 3, because 8 choose 5 and 8 choose 3 is equal. If you're not sure what I'm talking, so whenever you have some choosing, n choose r is equal to n choose n minus r. So don't make it a like kind of formula for this identity. It's just telling us the number of ways to choose r object out of n object is the same as number of ways to choose n minus r object out of n object. Why is that? Let's say r is like, let's say 5 in this case, right? You choose 5 question out of like 8 problem. The number of ways to choose 5 problem is the same as number of ways to choose 3 questions that you don't choose, like leave those 3 questions out. So which is why it's the same way. So instead of 8 choose like 5, I'm going to find 8 choose 3. And 8 choose 3 is just 8 times 7 times 6, which you can do this probably in your head, divided by 3 factorial. And then these guys will cancel. And then you got 8, 7, and 2, 6, 4. So these will be 8, and then 6 over 7 is our final answer. So I hope that makes sense. If you struggle on this process, then you probably need to work on combinations. That is number 5. So let's look at the next problem. So number 6 is algebra problem. So graph of the function is given in the domain between -5 to +5. And A, B, C are different numbers in this domain. And f of A and f of B is 1, f of C and f of D is 3, which of the following should be true? Okay, so like let's start with the f of A and f of B is equal to 1. So since this is 5, and then 1 will be somewhere right here, so I'm gonna draw the line. So let's say this is f of, like, let's say this is y equals 1, right? And we are gonna need 3 as well. So let's try in a different color. So let's say this is 3. Okay, so like this is y equals 3. And this was y equals 1. So like we have now a couple of things, right? So the first thing is it says A smaller than B. Like A is f of A and f of B is equal to 1. So that means we have this intersection, and this intersection. So one of these will be A's. Okay, and then one of these will be B, but A would be smaller than B. So let's say A is right here. So if this is A, then this could be B or this could be B, or if this is A, this could be B, this could be A. So we have these options. And A is smaller than B, and C is smaller than D. F of C is this, so C is gonna be intersection of this line with the graph, so which is gonna be this point, like this point and this point. So to achieve the first condition, I could choose A to be this number, and then B is this intersection. Okay, so the X value, and then C is this one, and then D is the last intersection. So A is to the left of all of these A, B, C, Ds, which is the smallest one. B is second one, but C is kind of close, but still, since the graph going like towards right, so C is larger than B if you like look at carefully. So which means this is possible. So the first option is okay. So we can immediately cross this one and this one. So the second one, so let's think about the second possible case. So we have C is smaller than A. So C is, maybe I should take these out of the way, but let me check. Oops. Okay, so we know this is possible. So C is smaller than A. So like C is F of C and F of D is 3. So C has to be this intersection or this intersection or this intersection. So one of these 3. So if I want to achieve this one, I like to get C as small as possible. So let's choose C is right here. And A is F of A1. So maybe A is right there. So if C is right here, A could be this one. And then B could be this one. And D could be this one. Yeah, I think it's possible. Like what I mean by if I choose like this is C as the smallest one, and then A is this one, because F of A is 1 and F of C is 3. So for these two good. And then B, I can choose like F of 1. So I'm gonna choose this is B. So F of B will be 1. And then D is gonna be F of D is 3. So I can choose D right here or right there. So either one works. So I could go with this as well. So this is better than the first one, easier to catch. And the last one says C is smaller than D. Okay, C is the F of C. So it should be this one or that one or that one. But we want to choose the smallest that is smaller than D. Okay, so if this is C, then this is going to be D. There's no way, because if I choose C right here, D has to be this. But let's choose this C because we want to get that smaller. Then this has to be D. But for the second line, there's only one intersection that is to the right of the D. So we cannot have 2 points that is going to be larger. So this is not possible. So I hope that's clear. So that's the choice C. So that was number 6. So let's look at the next problem. Number 7 is a geometry. So the AC is the radius of the circle with the center A. So AC is the radius. So that's my center. Okay. And BC is the radius of the circle that's centered at B. So this is the another center, that's the radius. So since this is equal to this, like if you look at this semicircle, this AC is radius, at the same time AB is also radius. And if you look at the this semicircle, and BC is radius and BA is also radius, meaning that these two semicircles are identical. And we are told AC is 12, so this is 12 and this is 12. And if you connect B to A, then I will get something, I guess, nicer. And that's also 12. So whenever you do have circles, try to connect those centers. That's gonna give us some figures that we can easily handle. And this is a triangle, which is a equilateral triangle that we can find the area easily by using 30/60/90, or we may just remember the area formula for that. And if you don't, you probably need to look at that as well. But this is another equilateral triangle, because if you take this center point and connect to this point, that's also the radius of this semicircle. And then if you look at it from the other perspective, that's also radius of the other one. So they are also equal. So we have two equilateral triangles. And what we want is area of the two equilateral triangle plus this piece as area, and then this area as well. You may find those separately because like if I wanna really, let me try this. Find that smaller region, because that is kind of making this question a bit challenging. If I find this region somehow, then area of the equilateral triangle easier to deal. But you know, I can take this is 60 degrees. If you take like AKB, like think about this is a sector, so you can take the area of that sector, which is 1/6 of the full circle, and subtract area of this triangle to get this red region. And then since we have 2 copies of those, and then you can double that number what you have and add it to area of those to apply a triangle, you can go with that. But instead of doing that process, I will see something much better than that. You know, since we have this triangle are equal, and then this region and this region is same, and then this region and this also same by symmetry. So we can just drag this red region to this piece. Okay, so I can just choose like and cross this from my question. And the question is now asking us to find something else. Like what does that mean? So like instead of finding that region, I'm gonna find this region. But what does that look like? So think about the center at B, and then there is like K is the point on the circumference, and then there is like this one. So this region that I shaded in green, that is also a sector as well. And then the angle at the center is 120. Maybe I should use different color, but I hope that is reasonable. So this is 120 degrees. So 120 over 360 is the part of the full circumference, and then pi times 12 squared. And this is 1/3. If you multiply 12 by 1/3, you will get 4. 4 times 12 is 48. So that should be 48 pi. And that is the choice C. Again, the reason why I just did, because I just took this red region and placed it right here because they have equal area. And then whatever we are looking for as shade is just this region that is in green. So that is easier to deal with, which is 1/3 of the full circle, and that is 48 pi. So I hope that makes sense. I'll see you in the next video.